We are in Unit 5. This is Notes 1. So far, we have done a lot with derivatives. We haven't done everything that we're going to do with derivatives, but we have done a lot. In this unit, we talk about antiderivatives and the relationship with indefinite integrals. So, first of all, let me introduce this to you. Let's consider this function. Let's say that we have f of x is 2x cubed. And we know if f of x is 2x cubed, that f prime of x would be, we're going to use the power rule, and I'm doing this slowly for a purpose. 3 times 2 is 6, and then we decrease the power by 1. And that's using the power rule for derivatives. So my question is, what if we didn't know what the original function was? What if we're only told that the derivative of some function is, let's say, 4x cubed, and we're trying to get to what is the original function? What function's derivative is 4x cubed, in other words? So in class, I would go through, people would give me suggestions on what this might be. But let's think about this logically. I know that to get the derivative, we decrease the power by 1. So that means that the power on this function must have been a 4. So we're always going to add 1 to that power when we're trying to find that original function, when we're trying to find the antiderivative. Okay? What happens with that 4? Well, we would, remember, to get the derivative, you multiply by your exponent. So the derivative of x to the 4th would be 4x cubed, right? So in other words, we have this 4 that was there, and we're dividing it by this 4. So it looks like we add 1 to the power, and then we divide by that new power. Let's see if it works. So let's say, let me have a different function here. I should have named it something else. Let's call it h prime. Let's say h prime is, oh, I don't know, how about 10x squared? So the question is, what was the original function? So we add 1 to the power, and then we divide by the new power. Does that work? Is that true? If our function is 10/3 x cubed, would the derivative be 10x squared? We would multiply the exponent times our coefficient, that would get the 10, and then we would decrease the power by 1, that would get the squared. So yes, that works. So add 1 to your power, divide by your new power, and that gets you your antiderivative. This is what we're doing. We're finding the antiderivative. Okay? Now, is this the only function? Is this the only function whose derivative is 10x squared? Let's go back to our g prime. So we had g prime is 4x cubed, and we said that g must be just x to the 4th, right? Is this the only function whose derivative is 4x cubed? Well, could g be x to the 4th plus 1? The derivative of any constant is 0, so the derivative of this function would also be 4x cubed. So would that, right? And we could put any constant there and still get that derivative. Okay? Let's think about that. Let's think about what the graph of these would look like. If we have just x to the 4th, let me zoom 4, that's just x to the 4th. What does x to the 4th plus 1 look like? There's the original function. There's x to the fourth plus 1. What about x to the fourth minus 3? X to the fourth plus 1, x to the fourth minus 3. There's definitely, you can clearly see what's going on here. So it's just a shift, right, in the vertical direction. Every one of these has the same derivative. So we call that the constant of integration. And anytime we're looking for a function whose derivative is given to us, we need to add that plus c, constant of integration. Okay? So these are antiderivatives. So x to the fourth plus c is the antiderivative of 4x cubed. If I can sharpen that up any. Okay? Each of these is an antiderivative. This one is called the general antiderivative. Okay? So we have some notation to talk about. We denote antidifferentiation, antiderivatives, with an integral sign. So we can say the integral of 4x cubed, we need to state what we're taking the integral with respect to. We're taking it with respect to x. So I'm going to write that dx. Okay? Otherwise, you don't know what variable to take the derivative with respect to. So the antiderivative, the integral of 4x cubed, is x to the fourth plus c. And we are using the power rule here. By the way, the inside of an integral is called the integrand. Okay. This is called the antiderivative. Okay. The c is called the constant of integration. So we have just learned the power rule for integrals. And the power rule for integrals says if, now let me write that down, power rule for integrals, or for integration. If n is any real number except -1, we'll talk about that, except for -1, then the integral of x to the n with respect to x is equal to, okay, we add 1 to the power and we divide by the new power. Add 1 to that power, divide by the new power, and then we add the constant of integration. Okay, so the integral of x to the 7th is x to the 8th over 8 plus c. Or we can write that as 1/8 x to the 8th plus c. Either way, of course, they mean the same thing. All right. Also keep in mind that these are antiderivatives, so we can have some the trig functions. The integral, the antiderivative of cosine x with respect to x. We ask ourselves, what function's derivative is cosine x? Well, we know the derivative of sine is cosine, so the antiderivative of cosine has to be sine. Has to be. The antiderivative of sine, we ask ourselves, what function's derivative is sine of x? Well, we need a negative cosine of x. Okay. What about secant squared? Well, we know the integral of tangent is secant squared. So this would be tangent x plus c. What about cosecant x? Cosecant squared x. Okay. The derivative of cotangent is a negative cosecant squared. So we need this to be a negative cotangent x. The integral of secant x tangent x dx will be secant x plus c, because the derivative of secant is secant tangent. And lastly, the derivative of cosecant cotangent would be a negative cosecant x plus c. All right, let's look at some more involved examples. So these are on your note sheet. Alrighty, number 1. Seems a little blurry here. Okay, number 1. Here's our function. And we're taking the antiderivative. The integral means antiderivative. Okay. So we're using the power rule. I start with my x. So x to the, we raise the power by 1. We divide by the new power. 8 divided by 4 is 2. Minus, raise your power by 1. Divide by your new power, 3. If we just have a 4 or any constant, we're just going to multiply that by x. Because remember, the derivative of 4x is just 4. Plus c, and we're done. You can always check these by taking the derivative. If you take the derivative of that, you better get your function, your integrand. Okay? All right, for this example, I first have, the only thing we have is the power rule. The only thing we have is the power rule, which says this. That's all we have. So, I cannot use the power rule on this guy quite yet. I have to write it in the form x to the n. So let's rewrite this as x to the 3/4 plus 1 dx. You can keep these parentheses if you want, or you can lose them. It doesn't matter. The dx is what ends your integral, so either way is fine. Now it's power rule time. Add 1 to your exponent. 3/4 plus 1 is 7/4. And then we're dividing by our new exponent, right? Well, dividing by 7/4 is the same as multiplying by 4/7. So 4/7 x to the 7/4 plus x plus c. You can always take the derivative and see if you get back your integrand, your function. Okay? This is not in the form yet that we can use the power rule. We have to pull any x, we have to pull to the top. So this will be the integral of 3x to the negative 7 dx. Power rule time. Add 1 to your power. That would be a negative 6. Divide by your new power. We get a negative 3/6, which is negative 1/2, plus c. That would be a safe stop spot, but these would be a multiple choice question. So as a multiple choice answer, they would likely rewrite this as negative 1/2x to the 6th plus c. Okay, number 4. This is definitely not in the form where we can use the power rule, because this is not in just an x to the n. It's not a series of x to an exponent. So not power rule time yet. We have to multiply this guy out, FOIL it out, distribute, however you want to say that. We're going to multiply it out. So this would be 16t to the 4th plus, don't forget your middle term, 24t squared plus 9 dt. Now it's time for power rule. Raise your power by 1, divide by your new power. Raise your power by 1, divide by your new power. Raise your power by 1, add c. You're done. Okay. In this one, I see theta squared, which I can take the antiderivative of. Raise your power by 1, divide by your new power, plus, now, the antiderivative of secant squared. What function's derivative is secant squared? That is tangent. So tangent theta plus c. That's it. Number 6 is not in the form where we can use the power rule on it. It has to only be an x to the n. Okay? So the first thing I need to do is divide. And I'm going to do our quickie divide, where we just take each term and divide by the x squared on the bottom. So this is going to be 4x cubed plus 2x squared minus 1 dx. Now we can use the power rule. Raise your power by 1, divide by your new power. Raise your power by 1, divide by your new power. Raise your power by 1, add c. You're done. Okay. Number 7 and 8, so exciting because we're solving our very first differential equation. This is kind of a big deal. First of all, whenever you hear the phrase solve the differential equation, know that your answer will be a function. Your answer will be a function. Okay? So you're looking for the function that satisfies this differential equation. So in other words, you're looking for the antiderivative here. So we have, I'm going to write this a certain way. I'm going to start with our f prime of x is equal to, and I'm leaving a space for a reason, is equal to 4x squared. That's what we're starting with. I'm going to treat this like an equation where we do the same thing to each side. So I'm going to take the integral of each side with respect to x. I'm integrating each side with respect to x. The antiderivative of f prime is back to f, because the derivative of f is f prime. I would have a plus c here, but I'm also going to have a plus c on this side. So I'm going to combine those two constants and make it one constant. The antiderivative of 4x squared is x cubed divided by 3, so 4/3 x cubed plus that constant. Now, be careful with this, because as I was saying that, I thought of something. On this side, we have f of x plus c is equal to 4/3 x cubed plus c. These c's are not necessarily the same. These are our general constant of integration. They can be anything. Maybe it is 0. Maybe this one is 5 and this one is 7. When I say combine your c's and make it a single c, think of this as c1 and the c2. When you combine it, it's just another constant. Okay? We're going to be doing that for the rest of the year. Okay? So now we have found a function whose derivative is this, but now we also have to satisfy this part. F of -1 has got to be 3. So now we're going to find the c value, the specific c value that makes this true as well. when we're solving the differential equation, we have to make sure that both of these end up to be true. Right now, it's not true. Right now, f of -1 has this, still the c. So anyway, so we're going to replace x with -1. If I replace x by -1, I get a -4/3 here, plus c, and that has to be 3. That has to be 3 to satisfy this. So c would have to be 3 plus 4/3. Let's see, 3 is 9/3, plus 4/3 is 13/3. So our function, f of x, is 4/3 x cubed plus 13/3. And this is our solution to that differential equation given that initial condition, given that condition. Number 8. We're going to solve this differential equation. Well, here I see I have f double prime of x is sine of x, and I'm given f prime of 0 is 1 and f of 0 is 6. Let's start with our f double prime of x, leave yourself a space, is equal to sine x. And we are going to take the integral of each side with respect to x. Well, the integral f double prime is f prime, because the derivative of f prime is f double prime. We would have a plus c, but I'm going to combine this c with the c on the other side. The antiderivative of sine, the function whose derivative is sine, is negative cosine plus c. I'm going to use this condition to find c. So f prime of 0 is negative cosine of 0 is 1 plus c, and that has to be 1. So c must be 2. So f prime of x must be negative cosine x plus 2. Now I'm going to repeat that because we have to get the original function. So I'm looking for f of x. So I'm going to repeat this process, this time with f prime of x. So there's my f prime. I'm going to take the integral of each side with respect to x. The integral of f prime is f. Oops, goodness. Is f. The integral of negative cosine x. So what function's derivative is a negative cosine x? That would be a negative sine x. Plus the antiderivative of 2 with respect to x is 2x plus some other constant. Now we're going to find that constant using this condition. So f of 0 would be negative sine of 0 is 0 plus 2 times 0 is 0. So that's just 0 plus c, and that has to equal 6. So c must be 6. So our function that satisfies all of these things is negative sine x plus 2x plus 6. That's our final answer. That's the function that satisfies those. And we could find that out. We could go ahead and take the derivative and the second derivative and see if we do get back a positive sine of x, and we would. Okay, that's it. Big day. This is a huge day for us. Lots of important things that we will be using for the rest of the year. You have to know your derivatives of trig functions. You have to know those because now you need to know the antiderivative of these. So power rule and the antiderivatives of the trig functions. Big concepts today.